There we go. What did I do with my calculator? I had my calculator here. Of course, I would misplace it right when I need it. So what is my largest A that would work?
3.
Yeah. It gives us 90,000. 4 gives us 160,000, which is too big.
So A is 3.
Mm-hmm. And then don't we do 142,884, that whole number minus the 90,000 now that we took out?
Right. So if we put in, if A is 3, so that would mean that's 300 squared, right?
Yes.
So we would do 442,884 minus 300 squared.
Yep.
What does that number give me?
52,884.
Cool. So the first digit is a 3. Now what?
Okay, so I'm kind of a little bit confused on the next step. We do
So then this number, so number 2, B, little b, satisfies uh 52884 has to be bigger than 200A times 10B, right?
okay, so we're just dealing with those two right now.
Right. So because this, of course, here in our squared, this is going to be 100A squared. This is going to be 100 A times 10B, 100A times 10B. This is 10B squared. Oh, quantity squared. This is 100 AC 10 BC right?
Yeah. Yep.
So, because like what they're looking at here is this term. So if we say x plus y squared, that's x squared plus 2xy plus y squared, right?
Mm-hmm.
So taking what we have for A, that gives us that big number has to be more than 6,000 B. So that gives us 8 for B.
So 8
Yeah,
is greater than b? Or is 8 equal to b?
8 equals B. Because that gives us 48,000.
Okay, yeah. Because if we went with 9, that would be too much. And we want the biggest one, right?
Yep. So we just subtract the 48,000 from the 52,884, which gives 4,884.
So, yeah, so what we want to do then after we found this number, it's 3, check to see if b equals 8 is correct. So that would mean we're going to check to see if 2 times 100a times 10b plus that 10b squared part is less than that 52,884, right?
Okay.
Can you move it up a little?
Yes, sorry.
Okay.
I was running out of room on my desk, so I had to.
Sorry.
Oh, 10b quantity squared. Parentheses matter.
Yes.
So does that work? So that'll be 2 times 300.
No, it's too big.
Too big. So that means we need to adjust, right?
Okay. So it,
Has to be 7 then, right?
yeah.
So let's see what happened there.
Because it did work for the first step, but when you add them both together, that's what we're checking.
Mm-hmm.
Make sure. Okay. So we didn't mess up a step. We just. Okay.
And that's not true. So try B is 7 now. So let's call this 3B. Um, 2 times 300 times 70 plus 70 squared. Is that less than 52,884?
Yes. It gives us a difference of 4,900.
Okay, so then so part 4 times C. So if we take what's our big number? 42,884 minus what do we do here? So we minus the number that we got before just to follow the lines. So that'll be 30 plus times, so that'll be 10. Feel like I'm missing something up here. I'm gonna go back to the original line. So this is 42,884 minus 100A squared minus, and so that line, so they want this to be, this is going to be bigger than 2 times. So our first digit was a 3, second digit was a 7, 0, C. So where are they getting that from? And then we need this number. So this is going to be 10B times 2 times 100A plus 10B, right?
Mm-hmm. Yep. So the 370 is coming, or the 370C is coming from the fact that we know A is 3.
Uh-huh.
That gives
B
us
is
300.
7.
Hmm?
B is now 7, right?
Yeah.
Because like now if we update our number, it should be a 7. So we know
Yep.
we have 370 of these ones when we multiply this part, right?
Yep. And then we have 2 of those.
Right, so we have that there.
So
And
that's the 2. Yep. But we don't worry about the C squared yet.
because then,
That's tripping me up. Okay, so that's the same with both the B and the C step. We do the other 2 first, and then we worry about that squared.
and then this would be 70 times 600 plus 70, right?
Yep.
So when I clean this side up, what do I get?
I got 4,900.
Is that what y'all got, Abby and Jared?
Yeah.
Yeah.
Cool. Awesome. And that has to be greater than 370 times 2 is 740.
Yep.
So
Okay, so I got C to be 6.
all right.
That gives us 740 times 6 gives us 4,440.
Okay. So 376 should be our answer.
Once we
No,
do
that's
the
not right because
Wait. Sorry. I got something else for that 4,900.
this part.
Yeah.
Let's see. Okay.
I
it's
got
this part. Let's go back.
5,984.
Okay, so that's gonna be 9,000, right? That's what we said. No, 90,000, right?
Yeah. Yeah.
And then 670 times 70. Maybe we mistyped something. Make sure I put in the right number of zeros. 1, 2, 3. Okay. Minus 4, 6, 9, and then 2 zeros. Is that what you got, Jared?
Yeah.
So we might have misplaced a 0 because I think I did something similar.
Okay.
So
And then,
then,
yeah, that gives us C equals 8.
but we want to check it, right? So then step 5, check. So if I did 378 quantity squared, what is that?
What's our number?
And
That ridiculously long, stupid number.
Ooh.
Nice.
So do you think this would work if I squared a 4-digit number?
We could try.
Let's try it. Just for fun. Oh, did y'all get all that before I just took it away?
Mhm.
We're good?
Yep. Yep.
All right. Granted, we didn't have this as a homework problem, but I'm just curious to see if this would work. So let's see. Let's try. What happens if I say 1234 quantity squared? Ha 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 ha. All right. This is not going to be ridiculous at all. So let's try to find the square root of 52275. And let's just try this as 1, 2, 3, 4 quantity squared. So that would mean we need to make our box or our square or do you think we could do the same? Maybe we just get a double digit for A.
Maybe.
That might save us some time, right? Let's try that
Mhm.
way.
Yeah, that'll probably be it.
Instead of making like 1,000 A and then try to find 4 digits.
Yeah.
Okay, so that's what we're looking at here. So if I do the same process again, 1, find the largest A so that 100 A squared is less than 1522756. So obviously if we make it 10, do I have a square button on? Where's my cue?
Well, obviously 12 is what's gonna work.
Yeah, so 8 equals 10 is too small.
11 works.
11's too small. Try 13, too big. So we find A is, does 12 work?
Yeah. It's 1,440,000.
Clear 1200 squared. Cool. Right. Then 2. Oh, and we want to do 1522756 minus that number. Bless you. Assuming that was a sneeze.
That gives us 82,756.
Cool.
Okay. So now we do
B should satisfy.
yeah. Should be small, so 2 times 100A times 10B. Yep. It's going to be smaller than 82,756.
So
If we plug in our A,
right, that's a 12 times 2. 24,000?
yes.
Um,
82,756 divided by
400.
23. So 3.44.
Jody,
Yeah,
is
so our
it
B should be
2400?
3. Sorry,
So
Abby,
B is
what?
3. Right. Well, I mean, we know the answer, so, but
I feel like it's, I don't know if it's 20. How is it 24,000?
so A is
12.
12, right? So that's 100 times 12 times 10 times 2.
Yep.
Oh, wait, where are we getting the 10 from to times? Oh, that, sorry. Okay,
You're good?
good.
Awesome.
Sorry.
You're all good.
Now let's see, check if B equals 3 is correct. So we want to check 2 times 100A times 10B plus that 10B squared square needs to be less than that difference we found, 82,756. Otherwise, we'll have to adjust. So that's 24,000 plus
900.
to be 9,000, right?
9,000. Okay.
No, 900. 30 squared is 9 with 2 zeros, 900. Right?
Yep.
Is that true?
Yes.
Yes.
Just by comparing place values, we're
Yeah.
good?
Yeah.
Okay, so that works.
Well, it's still right, but you didn't multiply the 24,000 by
2!
10B.
I was like really close, right? Those are really far. That should be 48,000, right?
It was so far away, yeah.
72, because you multiply it by 70. Or not, by 30. I believe. 24.
We have 100 times 12
Yeah.
times 2
720.
times 10.
No.
Whoa, where you go? Let's try this again. Come on.
Yeah.
So we said that's going to be 1,200 times B would be 30 times 2. Not plus 2, times 2. Oh, sorry, I'm talking to myself. That's 72,000. So it should be closer. Let's make that where you can see it. 72,000. Yeah. I was like, those are really far away. So yeah, that's totally true. Yeah, the numbers should be closer. All right. Now that we can properly type things into the calculator. So we now know we have a 1, a 2, a 3, and a 4. Okay, so step 4. Find C. How are we doing on time here? Oh, we're good. Because I wanted to show you Zhao Shuang. Yeah, I think that's his name. His proof. All right, so find C. So we take our big number. We're going to subtract 100A squared minus 10B times 2 times 100A plus 10B needs to be bigger than 2 times 1230C. All right, so assuming we can type things correctly into the calculator. So 12,000 squared. Are y'all getting the same numbers I am there?
Yeah.
Okay. 1,522,756 minus 1, 4, and then 1, 2, 3, 4 zeros. Ah, missed a digit. Oh, I already calculated that number. Why am I recalculating that? 2430 times 30. Did y'all get 9,856 for that difference?
Yeah.
So then I take that number and divide it by the 2460. So that would mean C is 4. And then for our last step, we check. One, two, three, 4 quantity squared equals 1522756, and that is true because we constructed that number.
Oy vey.
Yeah, I think we could have done it by finding a 4th digit, but I think that would make things more complicated.
Yeah.
Or even a 5-digit number, right? Because then we could find A to be a 3-digit number. So, this is neat. Annoying, but neat.
Yeah.
We have 5 minutes left. So for next time, see if y'all could present the cube one and see if y'all can figure that one out for me. That was number
3. Question 3.
So use the cube root algorithm to see if y'all can figure that one out.
It's number 3, you said?
Yeah.
Okay.
I could not find the quiz.
Oh, that's because it didn't upload correctly. So
Okay. I almost had a heart attack. I was like, there was a quiz? What?
yeah, well, I was gonna upload a quiz for y'all, and then when I uploaded it, it didn't. It was gone.
Aw.
Yeah, I don't know what
Alright.
happened. So yeah, and I think I'm gonna change it now. So
Okay.
I'll give you a new one.
Are we gonna have that for Thursday?
Friday.
Ready.
Have it
So
done
I'll give it to y'all today, and you'll have a few days to work on it.
by- Okay.
Okay.
Is that okay?
Sounds
Yeah.
good.
Cool. And yeah, I wanted to show you that proof real quick. It won't take long to show y'all. So like one of the homework problems was, why did I put that book? Was to take Zhao Shuang's argument into a modern proof of the Pythagorean theorem. So Zhao Shuang was that one with the like yellow box and the, oh, it's on page 205.
Okay.
Yeah, the yellows and the reds, and you take them out and move them around. So I found this link, and I'll put that up there for y'all. So let me change my share to screen 1. Nope. There we go. So you start off with that triangle with the base A and legs A and B, hypotenuse C, and then you're going to construct a box here that has length sides of A, and then you also construct this box. Are y'all seeing what I'm seeing?
No.
No.
Oh, damn it. Hold on. What's going on here? Oh, the share hung up. Sorry.
There you
There
go.
you go.
There we go. Okay, so let's start this over. So you have that triangle with the legs A and B, hypotenuse C. Then they constructed these 2 squares that have one with the length of A on both sides, and then one with another box that has length C for both sides.
Yep.
Then they take that triangle here and rotate it to within there. And then do that again to where they all fit nice and neat in that C-squared box, right?
Okay, yeah.
So then they constructed these lines here to create that yellow box. That was that yellow inside box. And then, so this distance should be distance A, right? Because that was translated from that box down here. And if this is length B, then that length, side length of that yellow box would be B minus A and B minus A. Y'all see them?
Mm-hmm.
Mm-hmm.
And then I hit 6, let's go. So then that would mean I have this box, this blue box here, or blue square. I don't know why I'm calling them boxes. This blue square that obviously would have area of C-squared, right?
Mm-hmm.
Then I have these 4 triangles inside here, or 1, 2, 3, 4 of those triangles in there that have area of A times B divided by 2.
Yep.
And then this one has B minus A quantity squared area. I add those all up, and that should give me C squared, which I simplify that expression to A squared plus B squared.
Okay.
So that was Zhaoxing's proof. That was that homework problem. Homework problem
And I think.
10. Faith, are you there?
Yep.
Oh, okay. It just, you were sitting very still, so I didn't know if you were frozen.
No, I'm all good. Thanks, though.
Okay. Does that make sense?
Yeah.
So let's go back to that picture in the book. So this is obviously a flipped version of that was online, but we can see there's the yellow box and so there's your picture, and those are going to be your red pieces.
Yeah. They just added another box on the outside.
You're right. So it's a rotated version of it, but yeah. That's cool though, right?
Yeah.
Mm-hmm.
So the Chinese had their own. And like I was reading through a lot of the like different dynasties, and it seemed like they were very independent of other civilizations when it came to talking about their mathematics. So it seemed like they were doing all this on their own anyways. So they discovered the Pythagorean theorem without necessarily consulting other people. So they've also, like, y'all remember Pascal's triangle, right?
Yes.
Right, Jared?
Yeah.
And you too, Faith?
Right.
So, like, they had their own drawing of it before Pascal even was talking about it. So that would be 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, for one.
That's
Wow.
interesting.
So yeah.
So, like these different things, it would be interesting to like look at Chinese textbooks and see if it's not called Pascal's triangle, but
Right.
Have a different
So
our like understanding of it is
right.
based on the Europeans because that's who we've given the name or who we've named it after.
And there was a lot happening in the world on their end too. So that was like, granted, now I kind of wish that I paid more attention to world history. So, like, seeing how the mathematics was developing along with the development of their civilizations is really neat. So,
Yeah.
but, yeah. So cool. Alrighty. I'm still working on those extra things. I'm working on those other quiz now. I'm gonna change the numbers that we were doing. And it'll be on this Chinese stuff.
Okay.
So yeah. So yeah. Any questions?
Nope.
Nope. Okay. Oh, and Abby and Faith, did y'all see my email last night about
Yeah.
class today?
We're watching that video.
Yeah, so that will be your class,
Okay.
and try to answer those questions the best you can.
Do you want like a essay form or just like answer each question?
So just try to like write up some notes on it, because when we get to class on next week Tuesday, I wanted to talk about them and then kind of like find shorter videos for us to kind of like think about it from those points of view.
Okay.
Because I figured that might be helpful when y'all get to student teaching.
Yeah.
So,
Okay.
and since you can't do field work, this is field work. So,
Sounds good.
and Jared, we need to get together about your advising.
Oh, yes, that is right.
Yeah. So just send me an email when you want to work on that, and then maybe
Okay.
we can meet through this.
Yeah.
Okay. Any other
Sounds good.
questions for y'all guys?
No.
No. Okay. Alrighty. Well, I will try to get this uploaded for y'all, hoping that it doesn't disappear on me. I lost Friday's lectures for some reason. Annoyed.
Would you mind sending an email out when you upload the quiz? Just
Yes, I
so
will
we have-
definitely do that.
So we have time to get it done. I appreciate that.
Yes.
Thank you.
No problem.
Yay.
All right.
Thanks.
Bye, guys. See y'all
Bye.
later.
Bye.